we're supposed to state if b minus 6 is a factor of that polynomial. So we're saying, is there something that I can multiply b minus 3 by to get the b cubed plus 4b squared, the rest of it. Okay, so I can find that out by dividing both sides by b minus 3. Okay. And so I can do that with long division or synthetic division. Oh, it's not b minus 3, it's b minus 6. Let's stop. Okay, so we put 6 in the box, and we just see if it divides evenly. If we get a remainder of 0, that means it is a factor. If we don't get a remainder of 0, then it isn't a factor. Things are not looking good. Yeah, so 6 times 40 is 240. Do I go on? So I'm going to add those, and I get 190, 187. And then 6 times 187 is a really big number, and it doesn't work. Okay, so no, not at all. Okay, so we'd have to get a 0 here, but we didn't get a 0. So that means it doesn't divide evenly. Okay, 29, back to complex numbers and operations. So
now I got it.
Imagine that there's a -1 there. And so we've got -6i. We don't need parentheses to protect that from anything. But then the -1, we have to distribute the negative sign to both of those things. So it becomes +1 plus 7i plus 6. Okay, so we do the real parts first. 1 plus 6 is 7. And then -6i plus 7i is positive I. And that's 29. Okay, let's do 31 now. We're multiplying two complex numbers together. So make sure that if there's a sign between them, you pay attention to that sign, whether it's adding or subtracting, but this one is multiplying. So we're going to distribute just like we would with polynomials. So 2 times -4 is -8. And 2 times 8i is 16i. Then we need to multiply the other term in the first binomial. -i times -4, and we get 4i. And -i times 8i is, -8i squared. So now we can combine some like terms. 16 plus 4 is 20i. And then what's I squared? So if I is the square root of -1, then I squared must equal, the square and the square root cancel each other out, I squared is -1. So I can replace that. It's like where if that was an x squared, we'd be stuck, but an I squared is just a number, it's -1. So I have -8 plus 20i, and then -8 times -1 is positive 8. So then we have a couple more like terms. -8 plus 8 is 0, and so all we're left with is 20i. And that's our simplified solution. Okay, last odd problem is actually a word problem that you love, but it is nice because it's where the solving of quadratics meets the real world. And you're always like, when am I going to use this? But in physics we use this. We use quadratics to model projectiles, things that are thrown up into the air. For example, this ball. And the quadratic, it has these different terms have meaning, like this is the initial height, this is the initial velocity, and this is acceleration due to gravity. And those are all in either feet or feet per second. Okay, so we're modeling it with this equation, and we want to know when the ball will hit the ground. Okay, h of t. So it's saying h, what could h stand for? Oh, I don't know, height. And it's saying that height is a function of, this is in function notation, height is a function of time. So at different times the ball will be different heights. So what is the height of the ball when it hits the ground? That means h is 0. So we set our equation equal to 0. 144 plus 128t minus 16t t squared. Okay? And we've done this before where we were like, oh, that leading coefficient isn't, let me turn it around, isn't 1, so we divide it out to try to simplify our lives a little bit. So let's see if we can divide all those terms by negative 16. So 128 divided by negative 16, negative 8t, and 144 divided by negative 16 is negative 9. So I have t squared, because I divided everything by negative 16. You could also put this in your calculator, and I get this equation. Well, this is factorable. Factors of negative 9 that add up to negative 8, negative 9 and 1. So t minus 9 times t plus 1 equals 0. And I solve for t. So t could equal 9 or t could equal negative 1. And if those are times, which one makes sense? The 9, okay, because we don't have negative time. Can't live in the past. So when t equals 9 what? It's 9 seconds in this case. So if we throw the ball at an initial speed of 128 feet per second up into the air from a height of 144 feet, that ball will stay in the air for 9 seconds before it hits the ground. This is really helpful when you're trying to throw something and land it in a certain spot. Perhaps if you were flying over some supplies to a place that needed those supplies in a cargo plane and you wanted to parachute them or drop them out of the plane and have them land in a certain spot, this kind of an equation can tell you when it's going to hit the ground, and you can make sure it lands in the correct place. So don't let anybody tell you that solving quadratics doesn't help you.
What?
Take physics.